Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida.
So, in this section, we will deal with all things pertaining to artificial intelligence, otherwise known as AI.
So, OpenAI is a non-profit research organization involved in aspects of artificial intelligence. It was set up independently by a group of people of whom Elon Musk is the most notable, and various research organizations which launched it a few years ago. OpenAI is a non-profit AI research company discovering and enacting the path to safe artificial general intelligence. Artificial general intelligence will be the most significant technology ever created by humans. OpenAI's mission is to build safe AGI and ensure AGI's benefits are as widely and evenly distributed as possible. We expect AI technologies to be hugely impactful in the short term, but their impact will be outstripped by that of the first AGIs. We're a non-profit research company. Our full-time staff of 60 researchers and engineers is dedicated to working towards our mission regardless of the opportunities for self-gain which arise along other pathways. Notably, they can earn a lot more money in industry. We focus on long-term research, working on problems that require us to make fundamental advances in AI capabilities. By being at the forefront of the field, we can influence the conditions under which AGI is created. As Alan Kay says, the best way to predict the future is to invent it. We publish at top machine learning conferences, OpenAI source software tools for accelerating AI research, and release blog posts to communicate our research. We will not keep information private for private benefit, but in the long term we expect to create formal processes for keeping technologies private when they are safety concerns. Recently, for those who are aware, they put out their first OpenAI 5 to play Dota 2 against a group of 5 humans and trashed them. And that's set the whole field ablaze. Now here we have a recent uploading of their product line of research, and so let's watch it.
We're working on teaching robots to solve a wide variety of tasks without having to program them for any one specific task. Here, a robot has learned to rotate a block into any orientation we'd like. Once it succeeds at that, we give it a new goal, and so on. The system runs on a human-like robot hand, and we use reinforcement learning and simulation to teach the robot how to solve tasks in the real world. To learn how to solve a task like this, we show it many different variations of the world, where the rules are slightly different every time. This is a technique called domain randomization, and it affects, for example, the color of the cube and of the background. However, we take this technique beyond just how the environment looks. We also randomize aspects like how fast the hand can move, how heavy the block is, and the friction between the block and the hand. Our learning algorithm sees all of these different worlds, and this lets it learn a way of manipulating the block that is very robust. Robust enough so that, eventually, we can accomplish the same task in the real world. To simulate all of these possible variants of the environment, we've built a system that runs the training processes in the cloud on thousands of machines. It's called Rapid, and we've used the same system before to solve complex video games. First, rollout workers collect experience from many different variations of the environment. They send this experience data to the optimizer, which uses it to improve the parameters of the model controlling the robot. Finally, updated parameters make their way back to the rollout workers to complete the cycle. One thing that's very interesting to us is how general the system is. Not only can it rotate blocks, but it can perform tasks with other shapes as well. If you wanted to write a controller for this task the old-fashioned way, you'd sit down and write out exactly, if I'm in this position, move this finger in this direction. If I'm in this other position, move here, and so on. It's very meticulous. Instead, our system can learn to manipulate objects of all kinds of shapes without any additional human help. We hope that with this approach, we can solve more and more complex tasks in the future, so that we can go even further beyond what today's hand-programmed robots can do.
Interesting. So let's take that out of there. Come back to where we were. Hopefully I can find out where we were. Let's come back over here. So yes, now they're developing a hand for manipulation, which is the next add-on to what's going on out there. As we know, Hanson Robotics is developing Sophia, which is a robotic head with some kind of artificial general communication capabilities, although that's overdubbed with kind of standard lines. And Boston Dynamics is the foremost robotics company in the world, owned by SoftBank now, who have some independence, and we're working on a quadruped as the most suitable version for any commercial application. So another little stepping stone towards when a real robot with real capabilities will be kind of formed. That's very interesting.